in this video, we're going to talk about multiple integrals. So in this chapter, we will extend the concept of a definite integral to a function of 2 or 3 variables. In this video, one, you'll be able to first know how to solve for double integrals given the regions, know how to use calculator to solve for double integrals, and also a review on the single integrals with their intervals. So in this case, we are going to handle multiple integral, whereby you're going to talk about double integral and a little bit single integral for you to understand what it's about. So for the derivation of a definite integral, we consider the area under the curve, right? So to do so, we broke up the intervals a, that is x is greater than or equal to a, less than or equal to b, into n sub intervals of with change of what x, and choose a point xi from each interval. So in this case, these are, we've plotted, we have some area under here. We have 1, 2, 3, 4, and in this case we are supposed to find the area. For example, let me use the toughness of a material. When you draw the stress strain curve, and we have this, and we are supposed to find the toughness of this. What you need to do is that the toughness is the area under this what surface, right? So how do you do it? Then we are just going to take the integral with the interval from here to here, which is the what, the strain. So if the interval here is a and the interval here is b, what you do now is that you are taking from a to b, and then we will take the formula, which is equal to the Young modulus times the stress, and then we'll what, integrate. So you want the area under this, then you do single integral, right? So in this case, let's move down to show you what I was trying to explain. So considering the figure above, right? Considering the figure above, single integral can be defined as I explained, the area is equal to a. So the a and b are the intervals given to you, and the function is what? F of x and dx. So in this case, you are first going to integrate the function of f of x, then you're going to put in the intervals, then solve it very simply. So this, we are going to do like this is for area. So when integrating a function of 2 variables, we will integrate over a region. So in 2 variables, we're going to integrate over what? A region, right? But with the single variable, we just do it over an interval, right? So we start by assuming that the region in R exponent 2 is a rectangular region. Yes, it's a rectangle, right? Which will denote it as the following. So let's kindly pay attention. I'm going to explain something here. So then we have a rectangle, which is the R, and it's given to us by this and this. How do we do that? So what it means is that the ranges of x and y are, this is for x and this is for what? Y. Always note that the first one is for x and the second one is for y. So in this case, in a typical question, they're going to give you values for a and b, c and d, and then you will take it as an interval, right? So in this case, for the ranges of x, x is what? Greater than or equal to a and less than or equal to b. I hope you understand. And for y, y is greater than or equal to c, less than or equal to d. So in this case, we are going to find the area above a region, right? But not an interval. So this leads us to double integral, right? So with double integral, but let's consider this one. When considering the curve of the surface x given by graphing the function of f of x and y over the rectangle. So this is a rectangle, and when we trace it up, this is the curve, and this curve, when projected down there, we're going to get a rectangle. In this case, we are going to use the rectangle to find the area. So that's why they give you r, which is equal to the x and the y, whereby the x is an interval and y is an interval, right? Yes. So the same thing applies here. When finding the volume, in this case, we have 2 intervals given to us. So the volume is what? The double integral of what? The function dA. In this case, let me explain the A for you. With dA, when solving, the A changes to what? Dx or dy. It depends on you. Why do I say that? You get to know that because the A can be dy dx or dx dy, depending on you how you position it to solve it, right? Yes. So let's get into it. Let's go into it. So we have a theorem, right, which is the what? Fabini's theorem, and this Fabini's theorem makes us understand how we can arrange the dx and the dx and the dy, in this case which represent the dA. So if a function of s and y is continuous on R, whereby the R, I told you that R represents AB represents x, which is an interval, and y represents what, CD, then we finding the area or the volume, we finding the volume with that function. We are going to take that function, double integrate it with the function dA, and then here is the case. We've already established that this case is for x and this is for y. So for the x interval, it starts from what? A to B, right? And the y interval starts from C to D. So how do you arrange the A? I told you that the A can be the x dy or the y dx, depending on the position. So how do you position it? Let's get something here. Now note that when positioning it, right, you see here they wrote the interval with x. That means that it should also correspond with the x. And the interval of y should always correspond with the y. Now, the simple understanding that I'll give you is that always the one in the middle should correspond with this. Because if you take this one, right, the one in the middle is y, right? That means that the other one will be the x. I hope you understand this. So the interval you take in the middle should have the derivative of that. So if you are taking the interval of y, you should have the y. So here, let's take another one. If you want to take the interval of x in the middle, that means that we are going to integrate from what? A to B, the function, and what? The x will come in the middle, then the y. So in other cases, let's look at how do you arrange this one? The dy came first and the dx came second, right? So dy will come last here and dx will come first here. So it's a vice versa. Any way you understand it, it's very simple, right? Yes, it's very simple for you to understand. Arranging the area is very important when they give you the region, which is the rectangle, and how to arrange them is very important. How do I say it? You can just do that. The interval here is what? This is the interval correspond with y, and here correspond with x, the function. So when arranging it, the one that came first will come last, and the one that came last will come first. So here, this is y, right? And this is what? X. But when you're arranging it, which represent the dA, then which represent the dA, we just do it that the one that came first will come last with the derivative, and the one that came last will come first with the derivative. As simple as that, right? Yes. So the integral is called iterated integral. So this is called iterated integrals. In this case, we can also use calculator for this. Well, check the description of this video. There's a calculator work for you. I've done a video on how to use the calculator to find double integral, right? And it's very simple, but you understanding the concept here will help you know how to use the calculator to do it. In this case, the calculator is Calcio calculator, and I know it's allowed in exams. So that's one thing that I love. If you get understanding from here, and then you can use the calculator for it. So then let's try and take some example and see. Let's get into. So with double integrals are computed by a similar process with partial derivatives, right? Yes. So with partial derivatives, right? So we are going to apply partial derivatives here. So in this case, we establish that, right? AB represents what? X, and CD represents Y. In this case, when arranging it, the Y will come first, the dy will come first, and the ds will come last. We've done that. Yes. So how do we do it? Then how do we solve it? You solve the one in the middle first. When they give you a question, you solve the one in the middle first. So in this case, we are solving it with partial derivative with respect to what? Y. So you do partial derivative with respect to y, then you substitute the intervals into it. Then later on, you come and do the partial derivative with respect to x, and then substitute the intervals given to you. The whole I understand is that when you do the partial derivative with respect to x, y, and you put in the intervals, y will get any y again. Therefore, you are going to get a function in terms of x. Then you do the integration and then use your interval given to you and you get it. So let's see. First, you compute the double integral by first computing this. I told you the one in the middle. Always note, Okay, you can decide to take this side, but it should correspond with the x. But to be on the safer side, or for you not to be confused, what you must do is that you just take the one in the middle and then integrate with the interval, right? So you take the integral from c to d, the function of x and y dy. In this case, we are doing partial derivative with respect to y. So we compute this holding s constant and integrating with respect to y as if this were single integral. So as we've done partial derivatives from the understanding from partial derivative, that's what we're applying here. So you are going to do partial derivative. So then you are going to do it with respect to what? Y, right? And then after you are done with that, then we move on. After you are done with that, then you will do this, because at the end of this, the whole idea is that when you do it with respect to y, at the end, when you put the intervals inside, y will be gone, right? You're not going to get any function with respect to y again. All will be in x. Then you find that you integrate with respect to s in this case, and then put the intervals inside. So let's take one example for us to understand very well. So then compute the following double integral over the indicated rectangle, right? So in this case, we know that this represents our x interval and this represents our y interval. Let's know that. That's one key thing you should know. So then how do we arrange this? Yes, so take a sheet of paper or you have a pen, do that, and let's see. And let's correspond that whether it will be correct, right? So we will integrate with respect to y first. It's not compulsory for you to integrate with respect to y first. It depends on you, right? But what I'll tell you is that take the function which is very easy that you can integrate first, right? So then how do you arrange it? Let me arrange this. Let's see arrange. So we do integral, right? Double integral. So in this case, we are doing y first. It means that what? X will come first. So we have 2 and 4, right? And we have the integral of what? 1 and 2. And we have the function which is 6. This is the function of the function f of x y, which is in this case is 6x. In this case, this is 6xy squared. And the dA here, we've arranged that, we've established that when you bring it first, this is x, so x will come last. So we have dy here and dx. I hope you understood this. Yes, so then what they are saying that because this is in the middle, we take the middle one first. So we are going to integrate partially with respect to what? Dy, right? Yes. So let's go. So how do you do the partial integrals, right? With the partial integrals, I think let me go through with you guys. So when you are doing partial integrals, right? So this is 6xy squared dx. That's what we are taking. So you know that with integration, we'll then add 1, right? Then we'll divide it by the exponent. So in this case, we are not tackling x. In this case, x is a constant that we are holding here. So we are just going to deal with what? 6y squared. In this case, we are doing like we are doing a single integral, right? So 6y squared, how do you integrate? You add 1 to the exponent, that will be 3, divide by 3, which will give you 2xy cubed. I hope you understood that, because we are taking y as a constant, right? But in this case, when y or when x is standing alone, do you know what you do? You add y to x. Let me explain something to you. For example, if I'm having 6, maybe xy, maybe plus, maybe x, and I'm doing this partial integral with respect to y, you know that here you're going to get what? 3xy squared, right? Plus, this will be x and y. Why do I say that? See, with the partial integral, right? The partial integral is different from the partial derivatives. In the partial derivative, when we are doing with respect to y, this becomes 0. But in the partial differential integrals, when you are doing it, you just add the constant that or the function in which you are doing partial derivative to it when it is standing alone. So in this case, the whole idea is that when you partially differentiate this, your answer, you should get what you integrated, because the vice versa of integration is what? Differentiation. So let's integrate this with respect to what? Y. With respect to y, you bring the 2 in front, that will be 6, then subtract 1, so you're going to get 6xy. Then with respect to y, when you differentiate y, you're going to get x. So we had it correct. That's the whole idea. So when we are doing partial integration, right, when the function that you are finding, the opposite variable is standing alone, you just add it, the function you are finding to it. For example, as I said, if it's 6xy plus x, when you are integrating this, you hold x constant here and you integrate, you are going to get 3xy squared. But plus, with this case, we cannot say this is 0. You just add the function that we are doing, and in this case, it's x, so you just add y to it, whereby you get what? Xy. I said, I'm repeating this again. The whole idea is that when you get your after integrating your function, the answer that you get, when you differentiate it back, you should get the question given to you. So in this case, let's try and differentiate this back, whether we get 6xy squared with respect to the partial derivative with respect to y, right? We are going to get this through coming, that will give you 6x, and you subtract 1 from, you get what? 6xy squared is correct. So after you've done the partial integral, you just do that, you get 2xy cubed. And in this case, you're going to put the intervals inside given by the what? The y. So you put 2 inside, then minus the 1. And this is what you get. You're going to get 16x minus 2x. And then you do your integral, right, with respect to what? X. And I told you that after you've done it with respect to y, at the end, you should get all the answer in what? In x. Then you what? Do the partial what? Derivative. In this case, you don't do partial derivative because the variable is in one single variable, which is what? X. So you do the normal integration and you are going to get, you just subtract, you get 14, right? Then when you integrate, what are you going to get? Plus 1 divided by 2. So you get 7x squared. Then you put the what? The intervals inside. As very simple as that. The key thing is that you should be able to do the partial integrals. I have explained it. Now let's take another one in case it's a different way. So then we are partially integrating this with respect to y. No, with respect to x rather. So with respect to x, what do? This is 6xy plus y. We hold the y constant here, right? So when you do that, you're going to get plus 1, you're going to get 3x squared, right? You're going to get 3x squared. Then plus, in this case, y is standing alone, but we are doing the partial integral with respect to x. So you're just going to add x and y. So you're going to get 3x squared plus what? 3x squared y. Sorry, there's y here. We are holding the y constant plus what? Xy. Let's try and verify that when you differentiate this partially with respect to x, we are going to get 6xy plus y. So let's do that. When you differentiate it with respect to x partially, we are going to hold this constant, right? So this will be 6xy, we had it, plus we will partially differentiate x, which will give us what? 1. We're going to get what? Y. That is the whole understanding. Check the description of this video and also know how you can use the calculator to do this. So the alternative, right? As I told you that you can decide to do the x first or the y first depending on the position. So in this case, they brought the x. You see, this is y. They are positioned y first. That means that y will come last here, right? So always the middle one, we concentrate on the middle one. We concentrate on the middle one because it's very simple. So we are taking the middle one, which is the integral from the interval 2 to 4, 6xy squared dx. So we are doing partial integral with respect to x. So with respect to x, we are going to hold the y constant through here, right? Then integrate. We are going to get 3x squared y squared. Simple as that. And then we are going to put the intervals inside with respect to what? X. So at the end, you are going to get all the intervals in y. I told you. Then you put your simplify, then you integrate, right? And when you integrate that, you're going to get what? 12y cubed. And then you put the values inside, 84. So whether you do it the x first or the y first, all the same, you should get the same answer. And that would be very simple to do. Yes, very simple. Now, let's take this example again. Let's go through this. You try this in your sheet and let's see. So this is the interval for us in x and the interval for us in y. So how do you arrange it? It depends. So you can arrange it in this case. Let me arrange it here. So if you do this one first, right? If you are doing -5, if -5, and here is this is 5, sorry, -5 and this is 4, and you are taking 0 to 3, that means that we started with s, so x will be last here, so we are going to get dy dx. So in this case, we are going to do the middle first, which is that we are going to do the partial derivative with respect to what? and the partial integrals with respect to y. Let's do this. So let's see how we can do this. So you see, in this case, they did the one in the middle first, which is the partial integral with respect to y, right? Yes. So let's do that. I told you that when we are doing partial integral with respect to y, and the opposite variable, which is x, is standing alone, you just add what? Y to it. So this is the case that we add y to it, and here you do you integrate this whereby you add plus 1, which is 4 divided by 4, which will give you negative y exponent 4. Now, for you to verify that what you did was correct, is that you try differentiating this partially with respect to y, because we are doing dy here. So let's do it. When you do it with respect to y, you're going to get 2x, which is this. With respect to y, you bring the 4 here, subtract 1, you get what? 4y cubed. So it's correct. Nice one. Then you put the intervals given to you. So at the end, you're going to get 6x minus 81. Are you getting it? And in this case, then for integrate this, and you're going to get 3x squared minus what? 81x, because you're going to bring x here. And then you put in the intervals and you get the answer. So always, what I do is that for you to get it correct, after doing the partial integral, you try partially differentiating it with respect to what you did the partial integral with. And then if the answer is the same, it means that if the answer corresponds with the integrated one, it means that it's correct. So this is it. So we are going to note that if you can also do it in this case, that you can separate them individually, and the answer you multiply them. Are you getting it? So in this case, you can do the function of x and the function of y. Then you do it because the function of g of x will go with what? Dx, and g of h of y will go with what? Dy. And you take their what? Their intervals, right? And then after you are done, you just multiply them. So let's take example here. What they did was that we are finding the double integral of x cos squared y dA, and they gave us this. So in this case, we have this. We are going to, the function of g of x is what? X. So we have x, and the interval is from -2 to 3. -2 to 3 dx. Then multiplying the h of y is what? Cos squared y. And the interval is from 0 to what? Pi on 2. And you did that, dy. So the answer that you get, you find the integral, you find the interval. The answer that you get, then you multiply it. Right? It's very simple as that. So you can also use this concept to do it. Yes, that's how it will be. So you can also check the description of this video for the calculator work, but you understanding it is very important. I hope this video found you blah blah blah.